Hey you guys, we're going to start moving into the topic of density. You've watched a video or at least talked about mass and how to find it. You've talked about volume and how to find that, and that there's two components of it, volume by water displacement for irregular shaped objects and volume for a regular shaped object where you would find it length times width times height. Um, Remember, mass is how much matter is within an object, and volume is how much space an object takes up. When we talk about density, we are looking at pretty much what this definition says. It's going to be a ratio of an object's mass to its volume. Okay, so we're looking at the I-Hart density formula, and this is kind of a cute little way to remember how to set up the formula, because there is only one specific formula you'll have to use when you find density. However, if you set it up incorrectly, if you type it in wrong into your calculator, you can't blame the calculator. You typed it in the way you typed it in. So, in order to remember it, it's the I-Hart density formula. Now, remember, density is pretty much of a measure of an object's mass to its volume, meaning at the end of the day, we can kind of see if an object is going to float or sink without even doing an experiment. We can just do the math behind it. So I did mention it once upon a time, but the density of water is 1. So therefore, anything greater than 1 is going to sink. Anything less than 1 is going to float. So on this little I-Hart density formula, you can see that it's in the shape of a heart. So mass is on top because the top of the heart looks like an M, and volume is on the bottom because the bottom of the heart is a V. So if you ever forget which one goes on top, aka which one you type in first into a calculator, mass goes on top, and then volume on the bottom, okay? More times than not, your answer, remember in science we always have to have a unit of measurement behind our answer. So more than not, your answer will be in grams for the mass, and per, that's what that line is, per cubic centimeters. And remember, the G was mass and the CM3 was with regards to our volume. So we need to take both mass and volume and put it together because that is essentially density, okay? I'm going to pause the video really quick and kind of pick up in a second. All right, so this is going to be an example problem, and then I'm going to go to an older worksheet that we used to do that you may complete some of these problems on your own. And so let's try it. So if you look at this problem, it says the rectangular prism. So we know that this is going to be a regular shaped object because rectangles and squares are regular objects. So it's going to have a mass of 600 grams. So let me get my little pen here, and we'll do it in this pink color. So I have 600, and I can't type, remember, or like write on here. You have 600 grams, and that's going to be your mass. So I always recommend that for the I-Hart density formula, remember, your mass will be on top, so that's the M, over your volume. Volume will be on the bottom. So remember, if I'm setting up the problem, it's mass over volume, and I just found out that the prism has a mass of 600 grams. So remember, the G, grams, it represents mass, so you're going to always have a G. I recommend writing the G down just to kind of help you set up so you know that you still need it at the end for your answer. Now first we have to find the volume, because if you look, they only gave us a mass and this problem is asking for volume. So what we're going to do is do length times width times height, right? So what we're going to do, and some of you will know how to do this right away, but you'll do 5 times 10 times 6. Okay, perfect. So that will be our volume. Okay, So now volume equals, let's get our calculator, because some of you can do that in your head. A lot of you will probably need the calculator, so we'll do 5 times 10, and that equals this, times 6, and that's going to be 300. So we're going to do 300. And remember, we're probably going to use cubic centimeters. This one's meters, so we're actually going to have meters on this one. If you notice in the problem, it gives us meters. And we're going to put a 3 because we are using 3 different measurements, okay? So hang on one second, and I'll finish. Okay, so we just found our volume, and it's the 300 meters. So we're going to go ahead and plug it in. We're going to go ahead and plug it in here, and what we need to do now is divide. In order to do that, we're going to plug it in, so our mass is on top, 600 divided by 300, and that's going to be 2 is our answer, okay? But it's not just 2. I'm going to go ahead then and draw a line and kind of show you we're going to plug in our answer here. So it's going to be 2. And now we need to take our grams and our meters, cubic meters, and put grams per cubic meters. So yeah. Okay, so that previous example was a great example of finding the density of an object for a regular shaped object, like a rectangle, a square, or like a cube. Moving into the density of irregular shaped objects like this toy dino, remember, you're going to put that dino in the graduated cylinder, and then you're going to see the water level rise, and you're going to subtract those 2 different water levels to get the change in that water level. We're going to do an example on this video. So yeah. We're going to just kind of recap volume for irregular shaped objects. So I'll point out the slides that are really important. So let's see. We already really talked about all this. But what I want to remind you is that in this slide here, density for irregular shaped objects, density is really going to be a measure of how compact a substance is in a given volume. So the more molecules in a given volume, the greater the density. If you kind of notice that this one doesn't have many molecules, they're kind of spaced out, not very compact, least dense, might float. You get a little bit more compact, this one will be the most dense picture, okay? I mean, it makes sense. The fewer molecules, you'll have the least amount of density, like up here, okay? Another kind of tying off that slide, why do some things float? Well, objects with a density greater than 1 will sink. I kind of already mentioned that. They're going to be closely spaced together, kind of like this picture. Objects with a density less than 1 will float in water. They're going to be like less closely spaced, such as like right there, that picture, okay? So if the density of water is 1, will this penny sink or float? I hope you're going to say sink, because if you notice 7.2 is greater than 1. And if you've ever been to like a fountain at the mall or something and threw a penny or something in there, you would notice that all those coins sink. This little necklace thing of beads, it has a density of 0.75. Now, that's going to be less than 1, so hopefully you know that that's going to float, okay? Again, don't forget about the I-Heart density formula. It's going to be the same for these ones. We just find it a little bit differently, okay? So with that being said, let's go ahead and do this example, okay? It gives you the answer here, but we do need to know how to find this. So the first one says, what is the volume of the ball? Let me get my little pen, and yeah, so if you see we have 30, it looks like it's going up by like we can count by ones because each one of these ones is 10, but it looks like we can count by ones all the way through. So remember I told you about the meniscus in the previous video. You always do the bottom. So on this meniscus, it looks like it's about 35. So the beginning volume is 35. Put the object, a regular object inside, and then it rose to about, what is that, 39? Yeah. So 39. We're going to subtract the 2, and you get 4, okay? Now, this answer is not like what this is. This is going to be your density answer. So we just answered, what we did, we answered this first question, okay? Now, we just found the volume. We know this is the volume, okay? So now we need to find the density. Remember, density is mass over volume, okay? So what is the density of a ball if it has a mass of 20 grams? So remember they gave us 20 grams. So we know that grams is mass, so we can plug that in, okay? Then we know the volume we just found is 4, right? 4 milliliters. Awesome. So now we're going to plug this into the calculator, and you have to plug it in right. Your top one needs to be plugged into the calculator before the bottom. So 20 divided by 4 is going to be 5. And it's not just 5. Remember, you have to put grams and milliliters together because for density we use both mass and volume because it's a measure of mass and volume. So this is going to be our volume, or our density, sorry, our density. So I don't want this video to be too long because we're already at 12 minutes. So this is an explanation of both density of a regular shaped object and density of an irregular shaped object. Just kind of two methods on how to find density. Really the same thing, but just kind of two methods on how to find density. I'm going to make you one more video that goes over example problems, okay? Kind of just like a sporadic example problems that you can work on. And that video will be there to guide you, okay?